what role sensitivity analysis plays in understanding all those things we discussed?
Well, if you accept that the main things about model is to understand their conditionality. Now,
what it depends on, yes.
Yes, what makes them say what they say. Okay, if this is the real question, to understand why we should trust or not trust a model, then not only you want to map carefully the uncertainty around the prediction of a given model, but you want to see where this uncertainty is coming from, in a sense. And what makes the prediction about the positioning of a given facility in a given area uncertain? Why there is this latitude of possible choice? How could this become more easy to decide if we knew better something? These kind of questions is a question which are answered by sensitivity analysis.
Yes. Let's take an example. Let's think we are about to invest in what we want to invest. A solar panel. So what kind of things uncertainty analysis would be able to tell us?
Well, the uncertainty analysis would capture uncertainty which comes from the technology, from the material science, but also uncertainty capturing from the market, the demand, the competition, a myriad of these different factors. And the beauty of this is that not all of these uncertain factors are equally accessible to our knowledge.
Yes.
So imagine someone who is using this analysis of ours, and for him it will make a great difference if the uncertainty comes from a manufacturing parameter or from a market parameter.
Yes.
Because maybe he can act on the former with better research or better materials.
Yes. And can do nothing about the later.
And can do much about the later. So it is important to know where the uncertainty is coming from.
Yes, but wait, now I am totally confused. Are we talking about uncertainty analysis or sensitivity analysis?
Well, they go hand in hand. They really go hand in hand, because at the end of the day, what you have is to chart, to map. So you map the uncertainty, and this is an uncertainty analysis. But then if you wish, you chart where the uncertainty is coming from, and this is sensitivity analysis.
Okay, and should we do both?
I think so, because imagine by absurd that there is no uncertainty. I mean, the system is so well nailed down that you probably have no ambiguity in the inference, in the choice, in everything. So
True, even if we are talking about the past, there is some ambiguity, right?
Well, of course.
Yes. And if it is about the future, then it cannot be certain.
Yes. It is difficult to be certain, especially about the future, as they say. It's difficult to make prediction, especially about the future, as they say.
What is it? Is it from cartoon? No?
Yeah, something like this. Yeah. Or some wise guy who said
or
this.
some wise guy. Yeah. No. Yes. Okay. It's difficult to predict, especially the future.
Especially, exactly. That's the sentence. Yeah, that's it. Yeah.
Okay. So, what are the types, or maybe families even, of this uncertainty and sensitivity analysis that we can employ? What are the good choices and bad choices we can do about how we analyze our models?
Well, to many people it is intuitive that if I change one of these uncertainty in the input, I will see the effect on the output. And this is, and when they do this, they keep everything else the same, constant. It's not changed. Now, this is like if I were to take you and look at you, but look at you in the moment in which everyone is asleep. Yeah.
Okay, but I'm moving.
You're moving, yeah, but you are the only one left standing. Everyone else is frozen, asleep, or disappeared, like in a novel of Morselli. So you wake up in a world where everyone has disappeared but you.
I would feel very lonely.
You would feel very lonely, but I would not be able to study your behavior, because your behavior is conditioned by the person you have interaction with. And if you have no persons around you, okay, the same happened to an uncertain input, no?
Yes.
If the input is left free to act in a world where everyone else is frozen, I will not be able to say much about its behavior. And this is why we say when you study these kind of things, both uncertainty and sensitivity analysis, you must let all what is living live. no? Act, move, no? So you have to be global in your analysis.
Okay, so did I understand right? That when we're talking about me, when I'm alone, I'm one thing, and you cannot really judge my behavior, but generalize my behavior by just observing me being alone. But you want to put me into different social situations and see how drunk I get at parties.
Yeah, definitely.
What choices do I make when I talk to
sure.
my boss, and what do I do with the kids around, right? Like all of those things, and I would be different in all of those things, and you would want to see the aggregate behavior of me to judge me as a personality, perhaps.
The latitude, I would say. More than aggregate, I would see to see how far it goes in which direction.
Yes, how crazy I am in different...
How crazy it can be, yes.
Yes, how dangerous.
How dangerous it can
yes,
be.
okay, perfect. And then if we translate it into a solar panel investment, then does it mean that it wouldn't serve well for us if we only check whether the price of the solar panel would be different, our investment cost, right? Irrespectively of all other factors, to judge about the profitability of our idea.
Yeah, of course.
Then we want to change everything. The market price of electricity, if we want to sell it, our own consumption, how much we will need to pay the guy who will maintain our solar panel. Like everything needs to be changing together.
Well, maybe not everything, but everything which you have reason to suspect may impact on the decision you have to take. No? So, and then you will never have any guarantee that you have done your job in a thorough way. There will be something which you don't know, did not expect. This is unavoidable. No, there are things we don't know that we don't know, as they used to say. No, this is of course always there.
Unknown.
This will be always unknown. So, being humble and understanding that this will always be the case, still you can try to be as thorough as possible in exploring all things which you believe might affect the choice. No? And if you are unbiased, you'll be probably, if you don't have a particular interest in, which is not often the case, but imagine if you are completely unbiased and you have no particular desire or ambition toward one particular outcome versus another, you will try to map as carefully as possible all these circumstances.
Yes, that's true. But is it only the things that I suspect might influence, or is it also those that might change? And I know they might change, and even if I think they wouldn't influence much the output, I still want to include them into sensitivity analysis to see if they indeed have any impact.
Yes, because you want to leave the model the chance to surprise you in a sense, no? But then, okay, but a trade-off even then, because then if you include too much, then, you know, you may have something which you cannot handle. It's so complicated, you don't even understand yourself what's going on. So strike a right balance between giving the model a chance to surprise you and the other still having a model which you can interpret. No, it's simple enough to be interpreted.
Okay, yes, that makes total sense. And then what we were talking here about is practically one-at-a-time analysis, sensitivity analysis, right?
Yes.
Versus the global sensitivity analysis.
The global sensitivity
and
analysis.
Global sensitivity analysis is when everything changes and we check the latitude.
Exactly, as a statistician would normally do. When a statistician do design of the experiment, it never comes to their mind to change one parameter at a time. They always change in groups, and they do this in a way which is considered efficient by the theory of experimental design. But for some reason, sometimes modelers, you know, don't do that for a variety of reasons, including that
they're busy with their models.
One common reason is that if you change many parameters, the model may crash.
Oh,
especially if the model is a bit delicate, sophisticated,
heavy,
involves, I don't know, solving some nasty differential equation. You change too many parameters and, you know, the model jams. And so this may be a reason which push people to be careful with what they change. But still, this should not be an obstacle, because otherwise you may remain ignorant of things which can come back to haunt you later.
Yes. Andrea, please give me an example where a usage of sensitivity analysis was critical but wasn't done, and it led to a catastrophe.
Well, catastrophe, for sure. There are several which come from my mind, and we spoke about them in the manifesto. published some years ago in Nature. One was the famous Lee formula. This is what the formula for the rating of sophisticated financial products known as CSDO, which were at the root of the collapse of the economy in 2008. You remember the failure of Lehman Brothers and so on. And in fact, this mathematical formula, this model, which was used by the econometrician at the time to price those derivatives, was based on a wrong value, on a wrong formula for the possible joint failure of several mortgages. Because this is what CSDO were about, packing together a bundle of several mortgages and slicing them and selling them.
Isn't it? There is a movie about it, Big Shot.
Yeah. There are at least a couple of movies which describe this, and quite good. And so what happened is that this equation and the parameter in this equation, in particular the joint failure rate gamma, had been modeled in a period in which the market for real estate property was going up. So clearly this gamma was very low. The probability that two mortgages would fail simultaneously was low. But when the market changed direction, clearly this gamma was no longer at all realistic, and this is what happened. No? So all of a sudden, these bonds became close to junk, and there were a tremendous collapse in the market, and which led to all the recession which we then later experienced.
Another example?
Yeah, another example. The example, obvious example is what happened with COVID. When COVID arrived, everyone was unprepared, and one didn't know what to do. All of a sudden, a single mathematical model emerged from the confusion as bringing the light. And this was a model developed by the Imperial College by a scholar called Ferguson, which was a model agent-based for studying the evolution of a pandemic. But the point is that this model became the model to decide what to do during the pandemic. And important journals said that the model was actually very useful in convincing people and politicians to take action. In this particular case, the politicians were Boris Johnson and Donald Trump in their respective countries. Now, the point is that this model was not a model fit for taking policy decisions because it was a very large model, and the implicit assumption that one could calculate number of deaths gave an impression of certainty that was at odds with the reality of the present status of ignorance, and even more dramatically, the measure which were taken, the lockdown and all that, were measures which were, after all, very much bearable for some particular social class and very unbearable for other social class. And unsurprisingly, the class represented by the people developing mathematical modeling, the so-called laptop elite, so-called by someone, this laptop elite was quite okay with these measures of lockdown which were taken. One more example that I can recall. This was quite serious. This was a blunder made by two economists which made a mistake in calculating the effect of public debt on the growth of countries. This was Reinhardt and Rogoff. And they developed this theorem that when the debt of a country was, I remember, above 90% of GDP, the country could not grow. And this kind of theorem was used especially during the recession, to justify austerity policies, including in Europe, though the economists were from Harvard. Then it was discovered by a student in the University of Amherst in Massachusetts that the economists simply failed to include all the countries in the analysis because of an error on the spreadsheet Excel, which is surprising because you would wonder why two economists in Harvard program in Excel, but this is what happened.
Excel is everywhere.
Yeah, they discovered that this theorem was not holding, was false. No, it was false. But what is surprising is that, Ryan and Rogoff remained influential economists and the austerity policy were not changed.
So our advice would be to build the model, to be aware of the assumptions we make while we're building the model, to keep it relatively simple and do not chase full reproduction of the reality, right? And to discuss the results with involved stakeholders, and to run global sensitivity analysis together with uncertainty analysis, and discuss also those with all stakeholders, and be open to a next stage, next iteration of the process, to go back and restructure something, redo
Exactly,
something.
exactly.
Okay.
Probably what we are saying is that is a stage where the results are discussed. Not only the results should be discussed, but their uncertainty and their
Yes.
conditionality. This
Yes.
would be the message. No?
Yes.
This is must be a central topic of the conversation, as opposed to interrogating the model as a truth machine, taking the number coming out from the model and acting on that particular number. This would be probably rushing things in a sense.
Okay.